Hello and welcome to our next session. We are going to be looking at an example of how to draw a Pert and CPM diagram. And through that particular example, we'll be in a position to see how do we determine the critical path, how do we determine the slack activities, the slack time, how do we determine the early start and the early finish, the late start and the late finish for each and every project. But before we begin the process of drawing, there are two concepts that we need to familiarize ourselves with. One is normally referred to as forward pass, and the other one is normally referred to as backward pass. Forward pass, as the name suggests, we are moving forward. This is just but a technique that helps us to move through a network diagram. I'll be showing you a network diagram in a short while. Now, by first of all performing the forward pass, we are able to achieve what is the project duration. We are able to know the early start and we are able to know the early finish. So whenever we are drawing the Pert CPM diagram, we normally begin with what we refer to as a forward pass. The forward pass will help us to feel that the project duration, will help us to feel the ES or the early start, equally will help us to feel the EF. The next is what we refer to as the backward pass. The backward pass helps us to determine how late we can delay each and every activity without affecting the overall completion of the project. Now, unlike the forward pass, which begins from the first task, the backward pass begins at the end of the schedule and works backwards to the beginning of the tasks. The backward pass allows us to calculate the late start time, helps us to calculate the late start time, the late finish time. And through the backward pass, we're able to determine the late start as well as the late finish. The other thing that we need to know is that by performing the backward pass, we are equally able to determine the free float or the slack duration. In this given case is how long can we delay a project without affecting the overall completion of it. So we are going to do an example, and through this particular example we should be in a position to draw a Pert diagram. You may be presented with such a variety of tasks, and then we have the duration for each and every task, and then we have the predecessor. Predecessor simply means that a given activity has to be completed for the subsequent activity to start. For example, task B has a predecessor as activity A. So that means that task A has to be completed for task B to start. Similarly, you can see task C depends on task B. So task B has to be completed for task C to start. Similarly, task D is dependent on task A. It means task A has to be completed for task D to start. Task A relies on two predecessors, task D and C, meaning that both two tasks D and C has to be completed before task A begins. So step 1 is normally dividing of the project into tasks, assigning the duration as well as giving the predecessor. The next thing, step 2, is normally to determine the network diagram. So under the network diagram, what you normally do, you remember we talked of this particular symbol is the one that we normally use to represent a Pert diagram. So you are going to sketch it, and the only thing that you are going to be placing at the middle here is the activity names or the task names. So we have our task A, which is our first activity. Then after task A, you can see that task B comes after task A. So that's the reason as to why we are drawing that. And then we put our task B. We can see that our task C comes after B. So that's what we are doing. You can see from task B, we are going to task C. Task D, we can see it comes after A. So that means again, we come and draw our task D and we connect it from task A. And then we have lastly task E, which we are being told that it occurs after D and C are completed. So you can see we have task C and task D all joining to task E. So you determine the network diagram up to that particular point. The next thing is to determine the duration. So task A, and you remember it's the second box on the first row that we normally populate the duration, this one. So task A has a duration of 5, you populate there. Task B has a duration of 2. Task C has a duration of 3. Task D has a duration of 10. Task E has a duration of 2. So we populate the task durations. Step 4 is to perform what we are referring to as the forward pass. Now in the forward pass, we have said that we normally populate the early start as well as the early finish. Our early start means the day that our project is starting or the activities are starting. Ideally, they will always begin on day 1. Now the question is, how do you determine the early finish? Now the formula to determine the early finish is normally that one. We normally take the early start. For example, in this case, early start is 1. Then we add the duration. Task A is going to take 5 days. And then we minus 1. So this means 1 plus 5, that is 6. Subtract 1 is 5. So we populate 5 there. Now task A ends on day 5. Task B will begin on the following day, which in this given case is task day 6. It's equally going to take 2 days. So we have said you take early start, you add the duration, then you subtract 1. 6 plus 2, 8 minus 1, 7. Then we have task C, which is supposed to be beginning on day 8 because task B ends on day 7. The following day is day 8. So it takes 3 days. It's supposed to end on day 10. That is day 8, day 9, day 10. Now, we come to this particular task E. Task E depends on 2 tasks, task C and task D. So before we determine the early start for task E, we need to confirm the completion or the early finish for both task C and D. So we go back to task D and you realize that task A ends on day 5, task D begins on day 6, takes 10 days, ends on day 15. Task E depends on task C and task D. Task C ends on day 10, task D ends on day 15. Now the task with the highest early finish is the one that determines the early start of the successor activity. For instance, if task D ends on day 15, so this one is what is going to determine the commencement of task E, because even if task C ends on 10th, it has to wait until task D is completed, which in this given case is on day 15. So task D ends on day 15th, task E begins on day 16th, takes 2 days, and is completed on day 17th. That's how you perform the forward pass. The next thing is to perform what we refer to as backward pass. Remember, backward pass, we have said that you normally begin from the end. Now, something that you're going to realize is that our project ends on day 17, and we can, up to that particular point, say that the duration of our project is going to be 17 days. Now, we're performing the backward pass. Remember, the bottom squares are the ones that are normally used when you're populating the backward pass. So we populate with the latest time. So our project has to end on day 17. So the latest finish has to still be day 17. Then for it to end on day 17, how do we populate the late start? We normally take the late finish, we subtract the duration, then we add a 1. So we are going to take 17, we minus 2, that is 15, we add a 1, becomes 16. So for this project to have a late start of 16th, it means that it had a late finish of 15th. So that means we have to populate 15th and 15th as the late finish for both task C and D. For task C, we again, how do we get the late start? So we're going to take 15th minus 3, that is 12, we add 1, we get 13. Then for it to have had a late start of 13th, it means that its late finish was 12th. So again, we take 12, we subtract 2, it's 10, we add 1, becomes 11. But you are going to see that task A was feeding in task B and task D. So before populating our late finish, we have to determine what was the late start for task D. So task D similarly ended on day 15, then was taking 10 days. So we take 15 minus 10, that is 5 plus 1, that gives us a 6. So we can see that task B had a late start of 11, task D had a late start of 6th. So this one, task D, the one that with the shortest late start, is the one that is going to determine the late finish of the predecessor activity. So in this particular case, task D is determined by task A, and because the one with the shortest time period is the what is going to determine when task A has to complete. So task D has to start on day 6. So it means the late finish for task A has to be 5. And then 5 minus 5, then we add a 1, the late start for task A becomes a 1. That's how you finish on the late start and the late finish. Step 6, we now determine what we're referring to as the task floats, or the slack activities and the slack time. To determine the slack activity or the free float or the task float, what we normally use is you subtract the late finish from the early finish, or the late start from the early start, and you populate at this one. So this one is 17 minus 17 gives us a 0. This one is 15 minus 10, or 13 minus 8. Each of them is going to give you a 5. Then task D is 15 minus 15, or 6 minus 6, going to give you a 0. 12 minus 7, or 11 minus 6, going to give you a 5. Then task A, 5 minus 5, or 1 minus 1, gives you a 0. So what does this tell you? There are a number of things that we are going to note at this given point. One is that activities with a slack duration of 0, or a free float of 0, or a slack time of 0, those are activities on the critical path. Those are activities that cannot be delayed even with 1 day. Let's give an example. Let's see. Activity A, activity D, activity E, all of them have a slack duration of 0, or a task float or a free float of 0. That means we cannot delay these activities for any extra day. Task A ends on 5th, task D begins on 6th, ends on 15th, task A begins on 16th and ends. So if you are told to determine the critical path, I would say it's task A to task D to task E. Question number 2. You might be told which are those activities that we can delay without affecting the overall completion of the project, and by how many days. Now, any activity that has a free float which is not 0, or which is above 0, then that means you can delay that activity by the number of days that we have, or the weeks that we have populated there. So task B can be delayed with 5 days without affecting the overall project, without affecting the overall completion of the project. Task C can be delayed by 5 days without affecting the overall completion of the project. Because you can see task E ends on day 10, but task E will begin on day 16th. So that means task C has a free float of around 5 days. We can delay from day 10th all the way to day 15th without affecting the overall completion of the project. So having gone through that, I would want us to try this one. Draw the Pert/CPM diagram. We have determined the steps that you are supposed to follow. Determine the project duration for this particular task. Determine the critical path. Determine the slack activities and their overall duration. Now, something to emphasize here, this is F and I, capital I. This is J and this is J. Thank you for watching. See you in the next session.